Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 12 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1900. The earliest and the latest rounds where players compete. Okay, so now let's understand the problem statement. There is a tournament where n players are participating. The players are standing in a single row and are numbered from 1 to n based on their initial standing position. Player 1 is the first player in the row and player 2 is the second player in the row. Okay, so let's suppose 5 players are A, B, C, D, E. So how you give the indexing to this? Okay, so you give the indexing like this: 0, 1, 2, 3, 4. Okay, like this you give the indexing, right? But here in our problem statement, the players are standing in a single row and are numbered from 1 to n. Okay, so it is saying 1 to n. So let's suppose here in this case 5 players, n is equal to 5, and in our problem statement it is saying that players are standing in a single row and are numbered from 1 to n. Okay, let's say n is 5. Okay, so I can say 1 to n means 1 2 3 4 5. Okay, so I can simply say that this is nothing but my bun based indexing. Okay, bun based indexing. So see, indexing start from 1, right? So that is nothing but here 0, so 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. Okay, so this is nothing but 1 based indexing. So instead of starting from 0, we are starting from 1 to n. Okay, so we are going to use this thing later on in our code, so that's why I'm explaining this. Okay, so this is nothing but 1 based indexing. All right, now next, the tournament consists of multiple rounds starting from round number 1. In each round, the ith player from the front of the row competes against the ith player from the end of the row, and the winner advances to the next round. Okay, so A is going to compete against E, B is going to compete against D. What about this C? Okay, let's read. Right, when the number of players is odd for the current round, okay, the player in the middle automatically advances to the next round. Okay, so there is one match between A and E, there is going to be one match between B and D, and this C is a lucky guy. Okay, he automatically advances to the next round. Okay, so here we need to choose, okay, from this and from this, right? Okay, now, for example, if the row consists of the players like 1, 2, 4, 6, 7, player 1 competes against the player 7, player 2 competes against the player 6, player 4, lucky player, automatically advances to the next round. Okay, right. After each round is over, the winners are lined back up in the row based on the original ordering assigned to them, initially ascending order. Okay, increasing order. So n is 5, so means 1 to 5, and like this 1 2 3 4 5, increasing order. Okay, done. The players numbered first player and the second player are the best in the tournament. Okay, so they are going to give us some variable first player and second player. Okay, so these are nothing but the best players in the tournament. Okay, they can win against any other player before they compete against each other. Okay, so they can win against any other player before they compete against each other. If any two other players compete against each other, either of them might win, and thus you may choose the outcome of this round. Okay, so from here A and E, so A may win or maybe E will win. Okay, right, here also B may win or D may win. Okay, so we have to check all the scenarios, right? Okay, but if I say that this is my first player, right, so this player is always going to win, then there is no chance for B. Okay, and let's suppose this is my second player. Okay, so this is automatically moving to the next round. Okay, so now here I have to decide. Okay, in I will say that let's say A wins and then D and then C, or I can also choose this E, D and C. Okay, right? So if any two other players compete against each other, either of them might win, and thus you may choose the outcome of this round. Okay, so what we have given? We have given the integers n, first player and second player, and we have to return an integer array containing two values. Okay, integer array containing two values, the earliest possible round number, okay, and the latest possible round number in which these two players will compete against each other respectively. Okay, done. Okay, so now let's understand this same thing with an example, right? So we have to return this output. Okay, and this output, let's say this is my result. So in result, this is nothing but I can say result at 0 index. Okay, this position, and this I will say result at 1 index. Okay, I will also use this later on in the code. So that's why I'm explaining it like this: result 0, two values 3, and result 1 is 4. Okay, what are these values? This 3 is nothing but the earliest possible round number where there is going to be one match between 2 and 4. Okay, and this 4 is nothing but the latest possible round number in which there is going to be match between 2 and 4. Okay, so now let's understand how we are getting this 3 and 4 here. Okay, so now first round n is 11, so 1 to 11, done. Now there is going to be one match between 1 and 11. Okay, there is going to be one match between 2 and 10. Okay, so I'm going to write like this: 2 and 10. There is going to be a match between 3 and 9. Okay, there is going to be one match between 4 and 8. There is going to be one match between 5 and 7. And there, okay, this is nothing but mid. Okay, 6, right? That's it. Here if you notice one more thing, 1 and 11. Okay, what is the sum of this? 1 and 11, 12. 2 and 10, what is the sum of these two? 12. 3 and 9, what is the sum of these two? 12. 4 and 8, what is the sum of these two? 12. 5 and 7, what is the sum of these two? 12. Okay, so n is 11. Okay, so I can say this is nothing but n plus 1. I'm also going to use this in later my piece of code. Okay, there is one code line in which I will use this line. Okay, n plus 1. Okay, so here if you see uh, how matches are happening, 1 and 11, so sum is 12. Okay, 2 and 10, here 12. Okay, so this guy, this guy, and then this guy. Okay, this guy, and then this guy, this guy, this guy, this guy, this guy, and this is a mid. Okay, so 6 is automatically moving to the second round. Okay, this is first round, 6 is automatically moving to the second round. Okay, so now let's suppose in the second round, here you can say from this match 2 wins. Okay, from this match you can say 3 wins, from this match you can say 4 wins, from this match you can say 5 wins, and from this match you can say 11 wins. Okay, so you are going to get this result. Okay, second round, done. Okay, so here first player is 2. Okay, so I can say first player this A, and this is my second player. Okay, I can say this is B. Okay, so now here if you see 2 and 4, again here this is my A and this is my B. Okay, right? I can say this is my A and this is my B. Okay, now again there are going to be matches among these. Okay, in the second round. All right, so match between 2 and 11, match between 3 and 6, match between 4 and 5. Okay, now here this is my A, right? And this is nothing but 4. Okay, 4 here, this is nothing but my B. Okay, so definitely these two are going to win. Okay, so here we have to make a choice, 3 or 6. Okay, so let's say 3 wins. Okay, so this is my third round, right? 2, 3, 4. Now here if you see there is going to be one match between 2 and 4. Now we have to stop now. Okay, and what is this round? This is the third round. Okay, and we are writing 3 here, right? 3 is nothing but the earliest possible round number. Okay, so now here what is the use of this? If you see here, okay, so here if you just write the indexing of this in one waste, so you can say 1 2 3 4 5 6, 1 2 3 4, 5 and 6. Okay, you can say like this, right? Okay, there is going to be one match between 1 and 6. Sum is 7. 2 and 5, sum is 7. 3 and 4, sum is 7. And that is right. Okay, n plus 1. So, and nothing but this current site. Okay, same way here. 1, 2, 3. Okay, I'm not writing 2, 3, 1. I'm writing 1, 2, 3. Okay, just I'm giving the indexing only starting from 1. Okay, 1 based indexing. But here I will make sure that the player 2 is here. Okay, player 2 is this, and a player first player. Okay, first player is this A, and this is nothing but my second player. Okay, B. Okay, here also this is my first player, this is my second player. Okay, so here if you see 1 and this, okay, 1, 2, 3, 4. Okay, so that is right now. In this case n plus 1. Okay, right? Okay, so now in this case this and this, we are getting n plus 1 value. Okay, right? 1 and 3. Okay, 1 and 3, and both these 1 and 3 are not nothing but my first player and second player. Okay, right? 2 and 4 are nothing but my first player and second player. Okay, so if I just see the indexing of this first player 1, and this is at 1, 2, 3, okay, is equal to nothing but my n plus 1. N plus 1 nothing but the current size. Okay, so that is matching, so we have to stop. Okay, so from here what I can say, that I have to simply return the round. Okay, this current round. So what is this round? This round is 3. Okay, clear? This is what we are doing. Right now, this is the scenario which leads to the earliest round number. Okay, now same way, one possible scenario which leads to the latest round number. So again, same stuff you have to do. Okay, so now in this case what you are doing, you are making this one as the winner. Okay, instead of 11. Okay, so 1, 2, 3, say everything same. Now again match it, 1 and 6. Okay, 1 and 6, you can, let's make 1 as win. Okay, 2 and 5, definitely 2 is going to win. 3 and 4, definitely 4 is going to win. Okay, now here in this third round, now this time 1 and 4. Okay, match between 1 and 4, so we have to make 4 as winner. Okay, right, special player. Okay, then 4 and 2, now there is a match between this. Okay, and what is this current round? Current round is 4th. Okay, so we have to return the this 4 as the output. Okay, here, right? So this is how we are going to get the output for this example number 1. Okay, I will explain how we are getting this. Okay, but first understand why we are getting this output. Okay, so this is done. Same way, this is example number 2. All right, and these are the constant size, n value from 2 to 28. Okay, and first player, second player. Okay, 1, 2, less than equal to n. And here if you notice one more thing, okay, first player value is always smaller than the second player value, right? Okay, so first player value is always going to be smaller than the second player value. Okay, so now let's see how I'm going to solve this problem. Okay, so let me move this a little bit here. Okay, now let's take the first example only, right? N is equal to 11, and your first player is nothing but 2, and your second player is nothing but 4. Okay, so n is equal to 11, so we have to write like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here 11. Okay, done. All right, so this is done. Now here if you notice, we have to arrange the matches. Okay, match between this one and 11. Okay, we have to arrange the next match between 2 and 10. We have to arrange the next match between 3 and 9. We have to arrange the next match between 4 and 8, and we have to arrange the next match between 5 and 7. Okay, done. So here this and this. Okay, if I'm doing this, okay, player A and player B. Okay, so this, let's suppose this is one player and this is one player. Okay, so here if I'm doing this, but right now this is not my first player and this is not my second player. Okay, these two, right now this is not the case. So when we are stopping, okay, so we are stopping here. If you notice one thing here, so when we are noting, when we are stopping, when we are here. Okay, this and this. Okay, so border, this is also at border and this is also at border, right? Here also this is also at border, and here this is also at border. Okay, so by border I mean here if you see, uh, 1 2 3. Okay, normal indexing, if you give 1 to 1 base indexing, so 1 plus 3 you are getting nothing but 4. Okay, and this 4 is nothing but n plus 1. Okay, so I will check that scenario. Maybe my players are at the borders only. Okay, maybe my first player, let's say it is nothing but 1 and this is nothing but 11. Okay, so if this is the case, right, so in the first round itself there is going to be one match between 1 and 11. Okay, so because I'm going to get 1 plus 11, both this is not my first player, this is nothing but my second player. Okay, and this value is equal to nothing but n plus 1, that is nothing but this. Okay, so we have to just simply return in that case 1 and 1. Okay, there is no other way, right? Because this player is definitely going to have match with this one. Okay, in the first round. Okay, so this is how we are scheduling the match, right? One from this, one from this, then one from this, then one from this, one from this, one from this. Okay, like this. Okay, so in that case simply I'm going to return 1 1. Okay, so this is nothing but my base case. Okay, so if first player plus second player value is equal to n plus 1, simply return 1 1. Okay, so this is my first output. Okay, right, base case. Now let's see after that. Okay, all right, so we are here. Now let's see, this is done. Okay, now here we have to get the minimum number of rounds. Okay, so I will create two variables. Okay, let's say this is nothing but minimal number of rounds. Okay, so in this minimum number of rounds I will store the max value of integer. Okay, integers max value, let's say. Okay, and I will also create one variable max number of rounds. Okay, these are the two things that I need to return. Okay, max number of returns. So here I will store the min value of integer. Okay, initially, then later on I will update. Okay, so this is a normal process, right? Okay, so right now if you see what is my n value. Okay, so base case we can't return because my first player and second player, if I do 2 plus 4 6 is not equal to n plus 1, so definitely I'm not going to stop right now. Okay, so this is nothing but my round 1. Okay, this is going to happen now. Okay, so right now here if you see how many total number of pairs are there, so 1 and 11, this is one pair. Okay, 2 and 10, this is one pair. Then 3 and 9, this is one pair. Then 4 and 8, this is one pair. And then 5 and 7, this is one pair. Okay, so total 5 pairs are there. Okay, total 5 pairs are there. So how I'm going to get that shortly, so I can say that n divided by 2. Okay, because in each pair we have two values, right? So n by 2, so n nothing but 11 divided by 2, I will get 5. Okay, so 5 is nothing but the total number of pairs. Okay, that is done. Now also I need to make sure I need to check if there is any middle player or not. So how I'm going to check that? So if n modulus with 2, okay, and value comes out to be odd, okay, 1, all right, so that simply means that this is nothing but odd, right? So if this value is equal to 1, that simply means that there is one middle value. Okay, done. So how we are going to get the middle value? That is also very simple. N divided by 2. Okay, whatever the value, you are going to get 5. Okay, in that just add 1, so that is not what your middle value. Okay, n by 2 plus 1, so that is going to your middle value, right? Okay, clear. Now here if you notice one more thing, let's forget this fact. Let's forget this fact that our first player is this 2 and second player is this 4. So whenever there is going to match between them, so we have to make this as winner, this as winner. Okay, let's forget about this fact right now. Okay, let's ignore this fact. Okay, let's suppose this is not given to us, right? So now here if you see 1 and 11, match between 1 and 11. Okay, so maybe player 1 will win, or maybe player 11 will win. Okay, done. So same way here, maybe player 2 will win, or maybe player 10 will win. Okay, this is one way. Maybe player 3 will win, or maybe player 9 will win. Okay, and then here maybe player 4 will win. Okay, maybe player number 8, or maybe player number 5 will win, or maybe here player number 7 will win. Okay, so here we have two choices, 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 and here we have two choices. Okay, maybe from player 1 or player 11. Okay, from this, from this, from this. Okay, over here. Okay, two choices. So in total I can say this is nothing but 2 into 2 into 2 into 2 into 2, nothing but 32 combinations. Okay, 2 power 5, 2 power 5 is nothing but 32. Okay, Now you may ask how. Okay, so let me give you one simple example. Okay, let's say player 1, player 2, player 3, player 4. So I am saying this now, here two choices, here two choices, and then I'm just simply doing multiply, and I'm saying that 2 power 2 is nothing but 4 combination. So let me show you what are those 4. Okay, so if you observe now, match here p1 wins and then p3 wins. Okay, player p1 wins and here p4 wins, player p2 wins and here player 3 wins, or player 2 wins and here player 4 wins. Okay, so these are the 4 different ways. 1, 2, 3, 4. Clear? Right? So I have proved it, right? Okay, now same way, I will show you bigger also. Okay, so let's say this is p1, p2, p3, p4, okay, p5, p6. Okay, this is 32, so 32, in order to show it will take a lot of time, so I'm showing this smaller one. Okay, so here again 2 into 2 into 2, 2 into 2 into 2 is nothing but 2 power 3 is nothing but 8. Okay, so what are those 8? Same now. Here if you see p1, okay, fix p1, and then p3, p5, okay, then p1, p3, and p6. Okay, done. Then here now p1 and then go to p4 and then p5. Okay, so p1, p4, and p5, and then again p1, p4, okay, and then take p6, p6. Done. Okay, this is also done. Okay, 4 are done. Okay, 4 are done. Now next time here do one thing. Okay, so let me just copy these, okay, and paste them here. Okay, here, right? So now what are the next? So here instead of p1 you can take p2 in the start. Okay, so these are the 8. Okay, check. P2, P3, P5, P2, P3, P6, P2, P4, P5, P2, P4, P6. Okay, these are the 8. That's it. Okay, clear? So this is what we need to do, right? So this is done. Okay, so we have to check all the scenarios, right? All the scenarios we have to check. Okay, so in all the scenarios, here if you see, this is my initial stage, right? So here initially I have 11 players. So in the next stage, what is going to happen? 5 players I'm going to get. Okay, 1, 2, 3, 4, 5. Okay, 5 I'm going to get here, and there is one more. Okay, middle element. Okay, so total 6. Okay, then for this 6, okay, let's say 1, 2, 3, 4, 5, 6. Okay, these are the players. So now next time for this part we have to solve. Okay, so I'm breaking down this problem. Okay, this is bigger problem. Now I'm breaking it to smaller one. Okay, and next time only I need to check when my first player and second player is there in this smaller portion. Okay, so here I am ignoring this fact right now. Okay, I'm checking all the combinations. Okay, okay, and I'm going to get 32 such combinations. Okay, 32 such combinations, right? 32 and plus one more value is also there na? That also I need to add. Okay, so I will get all these combinations, right? Middle one we have to add, right? Okay, okay, so this is done, right? And that value is same only, right? Every time, so total 32 will be there. Okay, and in all this 32 only we have to add one extra 666 everywhere. Okay, that's it. Okay, so it's not 1 plus 1, it's just same only, but we have to add this extra. Okay, so until here 2 into 32. Okay, not 2 into 32, 2 into 5, and here just 1. Okay, so that is nothing but 32 only. Okay, right, clear. Okay, so this is done, right? So simple na, 2 into 2 into 2 into 2, and here there is one more player na, that let's say p1, p2, 3, p5, p11. Okay, p6, right? So p6, so into 1, right? So that's why done. Okay, so that is why 32 only, right? Okay, so this is done. All right, so what I'm saying, in this smaller portion, okay, I am checking 32 combinations. So next time I need to check for this one same thing only if my first player and second player is there. Okay, so let's say here for the next round, this is my case: 1 wins, 2 wins, 3 wins, 4 wins, 5 wins, and 6 wins. Okay, right?
So now again, if you see here, your first player, that is method 2, is there, and second player 4 is also there. Okay, so this is done. Okay, I will just add the indexing. Okay, one based indexing. So I will say 1 2 3 4 5 6 only. Okay, these are nothing from a special. Okay, again I have to check. Again I have to check the different combination, like 1 and 6 there is one match, then 2 and 5 there is one match, then 3 and 4 there is one match. Okay, so total 3 pairs. So among 3 pairs they are going to be matches. Okay, so okay, so now here, if you see this previous case, okay, I was getting 32. Okay, 32 combinations. So I can show these 32 combinations using binary numbers. Okay, using bits, right? So how I'm going to show that? So this is one way. Okay, this value is nothing but 0. Okay, this value is nothing but 1. Okay, using bits I will show you the 32 different combinations. Okay, this is how I write 1 or 2 in the binary form. Okay, right now, here, this is nothing but how I am going to write 3 in binary form. Okay, same way until 32 I will show. Okay, 31, right, because we are starting from this 0. Okay, so 1 2 4 8 16. Okay, so here, until 31 we have to show now, because we are starting from 0 0 31. Okay, so 31, how I'm going to write? 16, 16 plus 8 is nothing but 24, right? 24 plus 4 8, 28. Okay, 28, and then here, 2 30 and 31. Okay, this is 31, right? Okay, done. Okay, until here, so this is nothing but 31, right? Until here, total 32. Okay, so all these are ways, right? All these are different ways. Why these are the different ways? Okay, now see. So in these bits, okay, we have just zeros or ones. Okay, right, and we have these five positions. Okay, 1 2 3 4 5. Okay, so these positions are there, right? 1 2 3 4 5, and this one is fixed. Okay, for the next round, whatever is going. Okay, in odd case. In even case we don't need to take this. Okay, so here I'm saying that these are the 5 ways. Okay, these are the 5 positions. So here we have just zeros or 1. So I can say now, I can simply say that if my value is equal to 0, then I will say that, let's suppose my player which is on right side, that is going to win, or player on left side, it is going to win. Okay, or if I have 1, then I will say that my player on my right side is going to win, or left side is going to win. Okay, so we have only this 0 or 1. Okay, so let's say 0. Okay, so we have matches like this. Okay, we have here in this position we have match between this and this. Okay, let's say versus at this position we have match between this and this. At this position we have match between this and this. Okay, let's say same way here also, this versus this. Okay, this and versus this pair. Okay, so this value right now is 0. Okay, 0, and here if I just do the AND of this one, okay, this value 0 and of this one with 1, let's say left shift with 0. Okay, let's say add 0 index. Okay, add 0 index. Okay, 1 left shift 0. Okay, so here we both side we have uh 0, and here I have just 1. Okay, 1 left shift I. Okay, let's say 0 index. Okay, at 0 index I'm saying. Okay, these are the 5 positions: 0 1 2 3 4. Okay, these are the 5 positions. So 1 left is 0. Okay, so what we have, we are getting 0 only, right? So this value is 0, so I am going to say that, for let's say for 0 my right is going to win, for 1 my left is going to win. Okay, so here I have 0, left versus right. Okay, left versus right, I will explain this more clear way. Okay, left versus right. So just understand that these are the different ways, okay, in which we shows the bits. Okay, so in this, what I'm saying, that 0 0 0 everywhere now, right? So if 0, so that simply means every in every every case. Okay, every case here. Okay, this is match pair 1, pair 2, pair 3, pair 4, pair 5. Okay, everywhere R right side player is winning. Okay, here this is the combination: right side, right side, right side player, right side player, and here left side player wins. Then here what is happening, right side, right side, right side, left side player wins, and then right side. Okay, and here right, 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 left, left. Okay, right, 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 left, left. Okay, in this way, in bits, okay, in bits form, you are going to get the output. Okay, here all the players which are on left side, okay, on this side are going to win. Okay, so I have to check all these possible ways. Okay, now in these possible ways, if still my first player and second player is there, okay, if my first player, let's say here first player and second player is there, then for this also further we need to proceed. Okay, further we need to check, okay, until there is a one match between them. Okay, until my first player and second player both comes to the corner positions. Okay, right, in the current list. Okay, and I'm going to get the size of that particular list, and if first player plus second player is equal to n plus 1, then I have to stop. Okay, and then I have to just return the round from there. Okay, but let's suppose only first player is there, the second player is automatically removed. Okay, then I don't need to check this. Okay, then I need to cancel out this round, I don't need to check further. Okay, so now let me show you this simple thing. Okay, here for 5 players I'm showing now, let me show you for just 2 players. Okay, so then you guys will get a better understanding. Okay, but this is a normal process. Okay, so here let's use n is equal to 4 as our test case. So that simply means 1 2 3 4. So in round 1 the matchups are like 1 and 4, 2 and 3. Okay, right, so total pace is equal to 2. Right, so we need to simulate all 2 into 2. Okay, I already show you here 2 choices, here 2 choices, 2 into 2 4 different matches outcomes using bit masks. So 0 0 is nothing but 0, 0 1 is nothing but 1, 1 0 is nothing but 2 in decimal form, 1 1 is nothing but 3 in decimal form. Okay, so here 0 0. Okay, so match is like this, 1 and 4, 2 and 3. Okay, uh, between 2 and 3 there is match. Okay, so here this is nothing but left side players, right side players. Okay, so 0 0 means both times right side player means 4 and 3, so 4 and 3. 0 1 means right and then left, 4 and then 2, 4 and 2. 1 0 means left and then right, left and then right, 1 and 3. 1 1 means left left, 1 2. Okay, that's it, very easy, right? This is what, so I'm just going to use this. Okay, mask and 1 left shift I. Okay, why? Because this will give me the, this is just going to check whether that particular bit is set. Okay, whether I'm going to get 1 or not, whether I'm going to get 0 in the my output or not. Okay, if I'm not getting 0, okay, if the value is not equal to 0, then left as a winner. Okay, if value comes out to 0, then take the right as winner. Okay, that's it. So mask here, see. Okay, let I have already shown you here. Okay, so case 1, when your mask is 0, so that simply means this 0 0 in binary form. Okay, clear. Now here match 0. Okay, match 0, 2 matches 1 and 4, and your 2 and 3. Okay, so here if you see mask, mask 0 0 0 0. Okay, and here 1 left shift 0. Okay, so 0 1 means 2 matches are there na? So here let's say 0 index 1 index. Okay, so here 4 and 3 is winning for the very first time. Okay, so here if you see 0 and 1, okay, left shifting 0. Okay, so 0 means here this position I'm determining. Okay, and 1 means I'm this position I'm determining. Okay, so here if I'm doing this 0 0, and here I am left shifting 1 0 times. Okay, so that simply is 1 0. Okay, so if I'm doing the AND, so I'm going to get 0 0. So if I'm getting 0 0 false, so winner is going to be right side. Okay, right side player is nothing but 4 in the first setup. Now same way in the next setup 0 0, and here 1 I'm left shifting 1 time. Okay, so 0 1 left shifting 1 time, I will get 1 0. So here 1 0, I will get 1 0. This value is nothing but equal to 2. Okay, so this value is not equal to 0. If this is not equal to this value is equal to 0 also, right? And operation is there. Okay, 0 1 0 only. Okay, so that is why false. Okay, so again winner is right side. Okay, so players advancing to the next round is 4 3. Okay, so 4 choices in a 4 3. Then this is case 1, case 2 when mask is 1. Okay, then again you are going to do the same thing. Okay, so here 1 left shift 0, 1 left shift 1. Okay, so 2 positions are there now, 1 left shift 0 1. Okay, we have 2 position only every time, 0 and 1. Okay, 0 and 1. So that is why we are checking all the positions. Okay, and doing the mask and AND. Okay, so here in this case too, when mask is 1, so players are advancing to the next round is 1 3. Then in the next case players advancing to the next round is 4-2. In the next case players advancing to the next round is 1-2. Okay, so in the end these are the players advancing. These are the four ways. Okay, right, clear? So this is how we are going to solve this problem. Okay, so with the recursion we are moving further. Okay, and whenever this case arises like this n+1 I told you, okay, then simply means that both our special pairs, first pair and second pair, are at the borders, and when I'm doing the summation, okay, of their normal index value, okay, 1 and 2, this is what I will pass simply. Okay, so what I'm going to do, how I'm going to solve this problem, first see here 11, I am passing first player is at 2, okay, 4, and round starting from 1. Okay, this is what I'm passing, okay, initially. So this 2 and 4 automatically it is just showing the index only. Okay, 1 2 3, 1 based indexing. Okay, 1 2 3 4, so it is showing the indexing only. For next time when I am passing 6 players in the next round, so here 2 3 4 5 6 11, right? So for the 6 players 2 is at one position, so I am just going to pass the index of this. Okay, 4 is at this 1 2 third position. Okay, so I will pass this 3. Okay, for the next round 6 1 3 2 I will solve this smaller part. Okay, then smaller chunk, then smaller chunk, until this happens. From here I am going to turn the round. Okay, whatever the round I have. Okay, so this is how we have to solve this problem. Very simple. Now let's write the code. Okay, so very easy, nothing complex. Okay, just post the complete video. Okay, yeah, only then you will get the clear idea, okay, how to solve this problem. All right, so now let's write the code. Okay, so here from here I'm just going to call one my helper method. Okay, one helper method, or DFS, let's say. Okay, the DFS only we are doing, right, depth first search, right, smaller chunks we are dividing. Okay, bigger than this. Okay, then DFS on smaller portion. Okay, so here what we are passing n, and we are passing the first player, and we are passing the second player. Okay, and here you can say round 1. Okay, we are starting from round 1. All right. Okay, memoization we'll see. Okay, if we need I will also add that also. Okay, so first let's try to solve this without using memoization. Okay, let's see if we are able to pass all the test cases or not. Okay, so int DFS. Okay, so array, right, two values we need to return, minimum and maximum round. Okay, so DFS, so inside this you have to pass this same thing. Okay, so let me just copy this int n, int first player. Okay, let's say player A. Okay, player A, and here let's say player B. Okay, right, I'm going to call this DFS again and again now. Okay, player A, that's why I'm not using the common ones. Okay, player A and player B, and here round I'm passing. Okay, done. Okay, now here inside this what you need to do, here just one base condition we have to check na? If player A value, okay, in this if I add player B value, okay, if this value comes out to be n+1, okay, n+1, and okay, and player A is nothing but my first pair, player B is nothing but my second pair. Okay, if I'm adding these two I'm getting n+1. So definitely if in the first round itself I'm getting everything. Okay, so in that case I have to simply return what, I have to return array, right? Okay, return new, and here int. Okay, and here we have to just do a round. Okay, round is 1 only, and here also round. Okay, both min and max is going to be round only, right? We have to stop here. So this is one, nothing but my base condition. Okay, now we have to find out if they would face each other in the later rounds. Okay, so we have to simulate all the possibilities. So int min round. Okay, and here I have to take the max value. Okay, because here I need the min value later on, so I will update. So I can say integer dot max underscore value. Done. Now here int max round, and here I will say integer dot min underscore value. Okay, so that this is done. Then we have to determine the total number of pairs. Okay, so int total pairs is nothing but n divided by 2. Okay, I am writing the same thing, okay, whatever I explained in the story, okay, while explanation, same thing. And here I will check if there is some middle value. Okay, so boolean let's say has middle. Okay, and here how I'm going to check the it has middle or not. So n modulus with 2. Okay, if this value comes out to be 1. All right, okay, so here 1. Done. Okay, this is also done. So this is done. Right, now after that we have to represent the next round's advancing players. Okay, so we have to simulate all the outcomes. Okay, so for that I'm just going to create one array list. Okay, so list, and here I'm just going to pass integer, and here I'm going to say advancing players. All right, and here new array list. Done. Okay, now we have to try all the pairwise combinations using DFS. Okay, backtracking all possible matchups. Right, so for that, so here if you see advancing players, how we are getting those advancing players. So if I just move here, so these are the different scenarios. Okay, so total 32 are there, right? 2 into 2 into 2 into 2 into 2 into 1. Okay, total 32, right? So I can get this 32 uh in this way, 2 into 5. Okay, this is what I can do. Okay, or I can also do one thing, or I can left shift 1. Okay, how many times I can left shift this 1 5 times. Okay, so what will happen? 0 0 0 0 0 0 0 1, let's say. So now I'm left shifting 1 5 times. Okay, 1 2 3 4 5. Okay, so I'm writing 1 0 0 0 0 0. This bit value is nothing but 1 2 4 8 16 32. So 32 is output. Okay, so this is also one fast way to get this. Okay, so here I'm going to say for int mask. Okay, so from 0 to 32. Okay, 0 31. Okay, total 32, but from 0 to 31, right? So int mask is equal to 0, and here mask value, okay, is going to be less than 32. Okay, so 32 I can say 2 power 5. Okay, or I can say 1 left shift 5. Okay, so 5 is nothing but here total pairs. Okay, done. Clear. And here mask plus plus, that's it. Done. Okay, now this is done. Now here for the next round, okay, we need the set of integers. Okay, so let's use the tree set. Okay, automatically everything will be ordered. Okay, like 1 2, and next time 9 player wins, let's say, then 4 5. Okay, so 9 automatically go to the end. Okay, that is the use of this. Okay, tree set, and here integer, and here you say next round. Okay, integer next round. Okay, new tree set, and here this is done. Okay, and here I told you one more thing, that we are going to get some set of results only if my first player and second player both are there. Okay, in this possibility, in this scenario, then only I need to check further. Okay, then only there is possibility of the match in the upcoming rounds between them. Okay, but if even if any one of the player itself is not there, then there is no possibility of the match between them in the later rounds. Okay, right? So that's why here I will say that boolean include a initially. That simply means I'm saying that whether player A is included for the next round or not. Okay, so initially I'm going to set it to false. Okay, I will update this later on. Include B, I'm going to set it to false. Okay, now here after that, so here if you see uh, here also I have explained, but let's see here. Okay, so here these are the different mask values, right? This 0 1 2 3. Okay, so here I have told you now, if you see total 2 positions here, right? So we have to check this and this position. Okay, so now for all these masks, okay, 0 2 3, all these masks, I have to check first. For this 0 I have to check this and this. Okay, then for mask 1 Okay, I have to check this and this again. Okay, one left shift 0, one left shift 1, one left shift 0, one left shift 1. Then for the next marks, one left shift 0, one left shift 1. Okay, all the positions for this mask, all the positions again for this mask value. Okay, so this is why I'm running one more loop inside this. So I'm going to say int I is equal to 0, and how many total positions? Total position nothing but the total number of pairs we have. Okay, so I is less than total pairs, and here I plus plus. Done. Okay, and now here left side, so since this is one based indexing, so I can say I plus 1 here, and right side I can simply say n minus I. Okay, every time n minus I. So now you find out now, I 0, so left is 1, and here this n value. Okay, then next time I is 2, here n minus 1 value. Okay, this is how you are going to get n minus 1, right? So left and right. So here now we have to decide the winner, who is going to be winner. Okay, so how I'm going to get the winner? I'm going to apply the same formula. Okay, this formula. Okay, so here if mask value, okay, whatever the mask value that we have, okay, for this mask I am to do the mask of this with 1, and for all the positions I have to check. Okay, so positions I is equal to 0 less than total pairs. Okay, so 0 to 5, so 0 to 1 2 3 4. Okay, so like this. So I is less than here 1. I we have to left shift, but we have to left shift 1. Okay, so here I can say now 1 left shift I times. Okay, we have to check all the positions. Okay, if this value is not equal to 0. Okay, so for 0 we are just going to say that this is a winner is right. Okay, so if this value is 0, then I'm simply going to say that take winner as a right. Okay, otherwise I'm going to say that take the winner as left. Okay, so here I will say winner is equal to left. Clear? This is done. Okay, now here, okay, this is done. Okay, so whatever the winner we are getting now, so in the next round that winner is going to we take part. Okay, again, so next round dot add, I'm just going to add the winner. Okay, and here I will make sure that who is going to the next player. Okay, whether my player A is going to the next round or whether my player B is going to next round. Okay, okay, so I will check who is this current winner. Okay, so if current winner is equal to the player A, okay, the player A that I'm passing for this DFS search. Okay, this is what I'm going to check. Okay, then I'm going to update include A value to true. Yes, my player is going for the next round. Okay, I have already added this. Okay, in the winner. Okay, if my winner is player A, if my winner is player B, okay, then I will say that if my winner is player B, then update the include B value to true. Okay, right? Only these two things we need to check now for the next round, whether my player A and player B is going. Okay, so next round dot add winner. Okay, so if winner player A, then do this. If it is a winner player B, okay, then do this. If it is not player A player B, don't do anything. Okay, that's it, right? Now here one more case we have to check. So this is for total pairs. There is one middle value also, right? In okay, if has middle. Okay, if there is one middle value, so in the starting there was one middle, right, for the odd case. Okay, the n is equal to 11 example, so we have to add that value also. Okay, so how we are going to get the middle, that is also explained, I have explained already. So n divided by 2 plus 1, n divided by 2, okay, plus 1, right? And in the next round we have to add this, okay, middle. Okay, so here in the next round we have to add this middle. Okay, next round dot add this winner. Okay, this middle. Okay, and if this middle is a player A, then again include A, update to true. Okay, or if my middle is player B, then include B to true. Okay, if my middle is not player A player B, don't do anything. Okay, right, this is done, right? So if I'm adding the middle, I'm checking if middle is my player A, then I'm updating true. Okay, so we have to make sure we have to update this only if my winner, okay, or middle value whatever I'm taking is player A or player B. Okay, so for that we have to update these two, include A, include B. Okay, this is done. All right, so now this is done. Now here I will check. Okay, now very few lines of code is left. Okay, so if include A value, okay, include A value is true, and my include B value is true. Okay, so in that case only we are going to call the further DFS. Okay, so here I'm just going to create one list of uh, integer list is equal to new array list. Okay, and here what we need to pass, we need to pass this next round list. Okay, right, this is the next round list we are passing. Okay, so if I have both include A and include B, that simply means that player A and player B I have. Okay, so next time in this DFS I'm just going to pass the indexing of these two. Okay, indexing of these two players, right? Okay, so here int new index of A. Okay, so initially it was indexing only. Okay, 1 to 11 it was indexing only, right? Next time I'm passing this 2 3 4 5 6. So how I'm going to pass, this 2 is at nothing but 1 index, this 3 is at 2 index, this 4 is at 3 index. Okay, so I have to make sure now that these two players are there, so 1 and 3. Okay, for these two only I have to pass the indexing. Okay, so here I'm going to get new index of A is nothing but this list dot index of, okay, player A. Since this is a list now, indexing is going to start from 0. Okay, so here I'm going to add 1. Okay, to make it 1 based indexing. Same way, copy this, paste it here, int new index here B, and here list dot index of player B and +1. Done. Now here I am going to create one variable result. Okay, int result. Okay, so in the starting I told you this thing, result 0, this is nothing but result 1. Okay, so here in this result what I'm going to do, I'm going to call this DFS method again. Okay, this DFS, right, but with some modifications definitely. So here DFS, and here n is nothing but the current list size. Okay, so here I'm going to say list dot size. Okay, again I'm going to call this DFS helper method. Okay, this dot size. Here for the first player I'm going to pass new index A, and for this second player I'm going to pass new index of B. Okay, right, and here I'm going to update the round as my next. Okay, so previously I was passing this round 1. Okay, so here I am going to say round +1. Okay, next round to take round +1. Done, right? Okay, so now from this we are going to get two values. Okay, one is nothing but min round. Okay, and one is nothing but the max round. Okay, this, and here one is nothing but max round. Okay, so I can say that min round. Okay, so that simply means we have to take the min. Okay, and here max round means we have to take the max, math dot max. Okay, so here in the max round, one is max round you are going to pass. Okay, and here max round, that simply means result at 1 index. Okay, this is what you are going to pass. Same way here you are going to pass min round. Okay, min round value, you have to take the minimum every time, right? And here you are going to pass result of 0. Okay, so you have to make sure what is the min value you are going to get, what is the max value you are going to get. Okay, so here this is done. Okay, and in this result at 0 we are going to get that. Okay, the new values that we have now. Okay, and we are just going to compare with the previous min rounds or max rounds. Okay, this is done, right? Okay, this is done. Now here, now we have to simply return the result. Okay, so int result is nothing but new int, okay, array. We have to return the array now. So in array what we are passing two values, right? One is this min round and one is nothing but this max round. Okay, these two things we are passing. Done. Okay, now here, from here just simply return result. That's it, that's it. Okay, now let's run the code. So there are some issues, so let's fix that. Okay, so here this semicolon is missing, so let's add that. Come here and here, add this. Okay, now let's run it again. So see, all the test cases has been accepted. Now let's submit it and let's see if we are able to pass all the test cases without memoization. So nice, right? So we are able to pass all the test cases. Okay, now here we can also add the memoization also, right? So why there is a need of memoization if you want? Okay, we are able to pass this solution. Okay, we are able to submit the solution. But if you want to pass use Memoization, you can do that. Why? Okay, so here if you see number of matches, then player A position, player B position. Okay, right, player A, player B position, and here the rounds. Okay, rounds that you have covered, right? So only if you see here what are the number of things that that is changing. Okay, so here n, okay, player A and player B. Okay, so rounds we need to return, but here this player A and player B position. Okay, so here you can create, right? Let's suppose you are at round 11 and your player is A is at 2 and player B is at 4. Okay, this, right? Mm, this comes from some other upper portion. Okay, some, like here we are breaking the tree. Okay, same way there is one more branch of this tree, one more branch of this tree, one more branch of this tree. Here also I am solving the same part, 11 to 4. Okay, from this part also we are going to get the number of rounds when the actual match happen. From here also I am going to do the same thing, number of rounds when this match is going to happen. Okay, 11, 2 and 4. If I am calculating this thing here, then why do I need to calculate the same thing here? Okay, that is bad, right? Why we have to waste the time? Okay, so what I'm going to do, I'm going to store the output of this tree, okay, which I've already solved in the past. Let's say output, I'm going to say that here 26. Okay, some value. I'm not talking exactly like this problem, but let's say 26. So here I will say now, if this part I have already solved here and get 26, so from here I'm going to simply return 26. Now why I need to solve this further? Okay, so that is the use of Memoization. Okay, so if we are solving the same tree again and again, okay, so you can add that. So you can say here, you can create it like this, uh, 11, okay, and then just use hyphen this 2 player A, this player B as 4. Okay, and just create one string of this. Okay, 11 to 4. Okay, so you can use this as key. Okay, so let's implement this. Okay, if you don't want, then also it's good, but if you want to implement it, then it's very nice. Okay, so here private map. Okay, and here what we are passing, keys as string. Okay, and here we have to return the output in for this particular problem we have to return the array. Okay, min and max value, right? So let's say this is nothing but my memo, and here new hash map. Okay, done. This is done. Okay, this is done here. Now here how you're going to generate the key. So keys generation is very simple now, string key. Okay, so here n plus, and here you take hyphen. Okay, then again do plus, then here you have to just simply write player A, then again plus, then here again hyphen, and then again here player B. Okay, so this is how you are going to generate the key. Okay, and here just check if memo dot contains key. Okay, and in this just pass this key. Okay, so from here we have to simply return the output. Okay, so here you can simply say return memo dot get key. Okay, done, right? And here this is done. Okay, and here in the end you have to just simply store the result here. Okay, so here you can simply store memo dot put. Okay, so this key. Okay, when we are going to get the result. Okay, what is the result of this key? I am going to store it here. Okay, done. So if you see last time we are here. Okay, let's first run it and see if we are able to pass the test cases. Code is running fine or not? Yeah, code is running fine. Now if I submit it again, let's see. I am here. Now let's see. Now I come here. Okay, so definitely this is faster, right? So I hope that you guys are able to understand this solution, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.